And then I give you this chart. So we've talked about K is the bulk modulus, E is the Young's modulus, lambda is Lemay's constant, G is the shear modulus, V is a Poisson ratio. There's also M, which we haven't talked about yet, but that's the seismic modulus, which I'll show you just a second. So for an isotropic material, they're all related to one another. And so if you just measure 2, you can find any of them. And you can write the equation whatever's convenient to you and use it in any way that's convenient to you. Okay? So the way you read this is if you are given, say, K and G, so if you're given the bulk modulus and the shear modulus, and you want to know Young's modulus, it's 9K times G over 3K plus G, right? And, you know, here's the lambda just as we defined it. If you're given K and G and you want to know lambda, it's K minus 2/3 G. So the final thing is, you know, typically in a reservoir, the easiest way to measure, you know, the easiest way to measure moduli is from that should be on its own slide, but the easiest way to measure the modulus are from seismic waves. So we can show that the longitudinal velocity, seismic velocity, is the square root of m over rho, where rho is the density of the rock, and the shear wave velocity is the square root of g over rho. Right. So from this, we can go out, we can propagate some waves, we can measure the shear wave velocity, measure the density, that gives us the shear modulus, okay? So then we have one parameter. Then we can measure the P wave velocity. That gives us the seismic modulus, and we have 2 parameters. Of course, we don't typically use the seismic modulus in the constituent model, but then we have this table that allows us to convert back to, you know, whatever parameters we want for our constituent model. Okay? So that's all I have for today in terms of this is linear elasticity for an isotropic material. We're going to go on to learn about inelastic effects. So what happens when, especially when a rock is under pressure, it can actually have a lot of inelastic effects, like due to pore collapse and other things. And we'll continue to talk about that. All right?